In section 5.3 part 2, we take a look at an amortization schedule, which gives you an idea how your money is returned on that loan in terms of what goes towards the interest and what goes towards your principal. So I think it's a fairly good thing to look at. The main idea is that the yearly payment stays constant during the entire 5 years of the loan. You're going to keep paying back the same amount every single year. We're going to use the previous example of the $50,000 over the 5 years. During the first few years, most of the monthly payment goes towards paying the interest. Towards the end of the 5 years, most of the yearly payment goes towards paying the principal. So one way to see how these values change over time is to create that amortization schedule. The following is the beginning of the schedule. So at the beginning of the loan, we owe $50,000. Okay, at the end of the first period, we're going to pay that $12,522.82 that we just calculated. Okay, that's how much we're going to pay. But because we're paying 8% in interest, 8% times 50,000 is going to be right here, and that's the interest charge. So that first month, they're charging me $4,000 in interest. So I may be paying back $12,000, but only $4,000 is going towards my interest. So the difference between the $12,522 and the $4,000 is $8,522, and that's what's going to go towards my principal, the amount I actually borrowed. So what, 2/3 of it? And we're going to subtract this amount from what we owe to figure out what we owe the next year. So 50,000 minus the 8,522 gives us $41,477.18. Okay. So let's do one more line just to show you what it really is doing. So this is at the end of year 2. Now we're going to take 8% of the 41,000. So 0.08 times this 41,000 gives us $3,318.17. And that's how much of our $12,000 payment is going to interest. So the bank is making this money. This is their profit off of that $12,000 that we just made. The difference between these two comes out to be my loan, or my payment on the principal. So this year, year 2, $3,300 is going towards interest. $9,000 is going on the principal. So we're going to take this 41,000 and subtract this 9,000 off. And if we do that, we get 32,272.53. So you can see that the amount going towards the principal is increasing slightly each year, and the amount going to interest is decreasing slightly each year. And then to walk this forward in the next year, you would do the same process. You would come in and take 8% of the 32,000. That's going to go here. This number is constant. Subtract these two to figure out what's going towards the principal, and you subtract that off over here. And that's how an amortization schedule works. And what happens in the final line is at year 5, down here at the bottom, year 4, year 5, your principal is 0. And pretty much all the payment is going towards the principal at that point in time. Now let's walk a couple more examples just to get you some practice with it, and also show you how you calculate equity. You can find amortization schedules online. If you take out a loan, most of them, especially if they're a long loan, like house loans, will give you an amortization schedule that you can access to show where it's at. So example 3, the Johnsons purchased a house 10 years ago for $200,000. They made a 20% down payment of the purchase price and secured a 30-year conventional home mortgage at 6% per year on the unpaid balance. The house is now worth $350,000. How much equity do they have in their house now? Note, they've made 120 payments. This is a 2-step process. So the first thing we have to do is figure out what their monthly mortgage payments are to figure out how much they've paid into that loan. So that's the first thing. So we need to calculate or determine. So to do that, we know that they did what? $200,000 was the loan. However, we did put 20% down. So we're going to subtract off 20% of that purchase price, and that's actually the loan amount. Sorry, I misspoke. So 200,000 minus 20% of 200,000 is 160,000, and that's the loan amount. So this is the amount of the loan, how much they borrowed. So now we'll come into our amortization formula. So R is equal to the 160,000, the amount that they borrowed, times the interest rate in this case was 6%, 0.06. We're still making monthly payments over 12. 1 minus 1 plus 0.06 divided by 12. And in the beginning, they're supposed to pay for 30 years. So negative 12 times 30. Okay, and then number crunch that through the calculator. So I ended up with a payment of $959 and 28 cents. And that's how much they end up owing every single month for 30 years. Okay, now we're going to flash forward, right? So this is part 2. We now want to figure out their equity. What that means is if they sold the home at that point in time, how much would they be able to pocket after they paid the bank off? So we have to figure out what they still owe on the loan. So the first step is to determine what they still owe. That is a present value problem because we know what the monthly payment is. We know they still have to pay for an extra 20 years or 10 years in. So, let me say after 10 years, they owe another 20 years, and we're going to do present value. So again, what we're doing is what's the lump sum now that they would need to pay the bank to pay off the house? After living in it for 10 years, they still owe it 20 years. So that formula is going to be P equals, it's really just this formula rearranged. The monthly payment of 959.28. And then we're going to have 1 minus 1 plus 0.06 divided by 12. But up here, we're going to use 12 times 20, and that's a negative 12 times 20 because they owe 20 years still. All over the 0.06 divided by 2. And if you do that, you end up with them still owing $133,897.16. So after living in the house for 10 years, they still owe $133,897.16. But the problem tells us that the house is now worth $350,000. So if we take the $350,000 that the house is worth, minus what they owe if they were to sell it, $133,897, we'll get their equity. And that comes out to be the difference between those two numbers is $216,102.84. And that's their equity. So they would walk away pocketing $216,000 on that home loan or that home sale if they were selling it after 10 years. Your homework has a couple of equity problems. So. Okay, one more before we move on to sinking funds in the next part. So this is our final example in this part, example 4. Ruth and Paul have determined that after making a down payment, they could afford at most $1,500 for a monthly house payment. The bank charges interest at the rate of 6% per year on the unpaid balance, with interest computations made at the end of each month. If the loan is to be amortized in equal monthly installments over 30 years, what's the maximum amount that they can borrow from the bank? Well, wait a minute, we know R. They're telling me that I can afford a $1,500 a month monthly payment. We need to figure out how much we can borrow, which is the present value. So this is the amount that we're going to borrow, which is the price of the home. So we figure out how much we can owe, how much of a house we can buy. We also know that it's at 6%, so little r is 0.06. Still doing monthly payments because that's pretty much all what home loans are. And this is for 30 years. Okay. So this is a present value problem, present value of an annuity, not an amortization because we know what the monthly payment is. So P is equal to that 1,500. We'll have, 1 minus 1 plus. 1 minus 1 plus 0.06 divided by 12 to the negative 12 times 30 all over the 0.06 divided by 12. And if you do that, you end up with $250,187.42. So they can afford a $250,000 house is what this is